Hello, I'm Cesar Alejandro Brown, and my project was on the predictive analysis of distracted driving with machine learning and visual focus. What my project essentially does is it takes a live video of drivers while driving a car, and it creates a vector based off of their line of sight and remodels it in a 3D simulation to determine whether or not they are distracted by tracing where they're looking to a 3D representation of the inside of their car. For my project, I took 31 samples of different drivers driving around their vehicles, with ages ranging from 18 all the way to about 75. Each drive was between 10 and 20 minutes. I recorded the drives by placing a standard web camera on the dashboard and running the Python program while sitting in the passenger seat. Okay. The way that this program works is that it tracks your 3D pupil positioning and it tracks where you are looking. By doing this, it takes the distance between the corner of your eye and your pupil in order to track where you are looking. Then it creates a 3D line and resimulates your car in order to find the intersection between the simulated line and the simulated interior of the car. Here are all the drives that I've collected, with each drive having its own video and file. It would be tedious to go through and find individual examples, but I do have examples prepared in which drivers were found to be distracted. Here's the first example. In the first example, we can see that she is currently looking forward with her eyes on the road, showing that she is currently focused. Here's the 3D model of her car. Now watch what happens whenever she goes to look down at her wheel. When she looks down at her wheel, there's a high source of distraction from the bottom. Whenever she looks back up, she is focused once again. The second clip is slowed down so that it's easier to see. Okay. In the second clip, we can see that the driver is currently focused with no source of distraction with their eyes on the road. Here's the 3D model of their car, and this is the data being recorded. Now watch what happens as the driver begins to look down. As the driver begins to look down, there's a high source of distraction from the bottom. You can see that this correlates with his line of sight. Right there. Now watch what happens as the driver looks back up. As the driver looks back up, he is focused once again with no source of distraction or severity. The clip is now being played in reverse just to see once again. Here's a file from one of the drives I recorded. In the file, you can see the different data I collected. I collected data on the 2D origin of the pupil positioning, the 3D origin of the pupil positioning with the pupil X, Y, and Z position, the endpoint with the X, Y, and Z position of the gaze vector, as well as the Boolean parameter distracted, the direction, and the severity. The severity was determined on how far they were looking in that direction. For example, if I was looking forward but I was only looking down a bit, say like at the dashboard, that'd be considered lower to medium severity. Although, if I was looking down farther, say at my phone, that would be considered higher severity. So let's see if I can find some true values. So these are the true values right here. Oops, sorry. Between here and here. And these are about 30 frames worth of true distraction. Now, what that means is one frame is equal to 1/30th of a second, meaning that 30 frames equals 1 second. So in this, we can see that there are 31 frames, meaning for about 1 second, the user was distracted from the bottom with varying high to medium distraction. Each dataset is roughly anywhere between 10,000 to 20,000 frames. In this video, I can be seen being currently recording the data. We can see the driver, the 3D representation, and the output. On the dashboard is the camera I used to record the drivers.